Good morning, good afternoon, and good evening. Thank you for joining Jenkins Online Meetup. Our session today is Jenkins in Google Summer of Code, Midterm Project Status and Demos. My name is Alyssa Tong. I'm an org admin. Chris Stern and Bruno Varakten are also org admins and will be presenting with me shortly. So our lead GSoC mentors are also on this webinar to help answer any questions along the way. But the main presenters for the GSoC are the GSoC contributors, whom you will hear from very shortly. I need to change the next slide. All right, so the Jenkins Online Meetup is a community-driven virtual platform. Our goal is to inform, transfer knowledge, and share all things Jenkins. We are always looking for speakers, so if you have a compelling story to share with the Jenkins community, please reach out to us via that last link. Before we begin, a couple of housekeeping items. This session is being recorded. We will share the link on the Meetup page after this event. If you have questions, please put them in the chat window throughout the presentation. Our presenters and mentors will help respond to them accordingly. You can also find us on the GSoC Gitter channel as well as the community discourse after this event. And lastly, the code of conduct is fully enforced here as well as throughout our community. If you're not sure what that is, it simply means to show respect and kindness towards each other. Now I will hand it over to Bruno to walk us through the next couple of slides.
Thank you, Lisa. So on the agenda today, we'll talk about what is GSoC and what is Jenkins in GSoC, but we'll do that very briefly. Then we'll have the project demos by GSoC contributors. So we'll have 10 minutes per project, including the questions, by the way. And if ever we don't have time for questions at the end of each project presentation, then we may have some time at the very end of this meetup where you'll be able to ask the questions. By the way, we're talking about questions. If you have some, don't hesitate to write them down. You have a Q&A button somewhere in your Zoom window, and we'll try to answer them live at the end of each section if we have time. And if we don't, we'll try to do that at the end. I already said so. Next slide, please, Lisa. So what is Google Summer of Code? That's one of lots of Google programs. And this one has the goal of match open source organizations and projects with mentors and GSoC contributors. So each open source organization which is interested in being part of Google Summer of Code proposes to Google Summer of Code with some ideas. And then we also reach out to people being able to be mentors during the summer. So regular Jenkins contributors, people already being part of this huge ecosystem. And then we'll try to match them with GSoC contributors. So we already have at the beginning of the project ideas for various projects, and contributors give us their vision, their plan for the ideas during the summer. Then we have some grading, and in the end, we choose one person per project. We submit everything to Google, and they'll let us know later on how many projects we have this year. And I think we got 5 this year, as we had last year. Alisa, I think you may go to the next slide, if you don't mind. So this year we had 5. Last year we had 5. I think the year before we had 4. That's quite a lot of projects. That means that the Jenkins organization is seen by GSoC like a very good organization for GSoC, because our mentors are working hard, our mentees are working hard, and the projects are successful. They mean something for the Jenkins ecosystem. Most of the projects we had in the previous year were so successful that they are still used to these days. Some of them are used for statistic display, for example. Some of them are used to onboard new people to the Jenkins project. Some are there to help newcomers with understanding what Jenkins and on and on and on. You will find most of the explanation about what is GSoC for Jenkins on the main page. So Jenkins.io project GSoC 2025 project IDs. And if you want to have a look on the previous year's project, it's the URL you have just down there. I think I'm done, right? Yes, thank you. Chris, the floor is yours.
Thanks, Bruno. So this year we have 5 contributors, as Bruno said, and we have Chirag, Maeve, Ronak, Birgit, and Giovanni. Next slide, please. And for the mentors, we have 4 lead mentors, including Valentin, Weber, V, and me. And for the co-mentors, we have Kevin, Bruno, Viviento, Philip, Rajiv, Harsh, Shive, and Sweda. For our means, I think we've introduced ourselves. So with Lisa, Bruno, and me. So next slide. I think it's like, yep. Back to you, Lisa.
Yeah, so we will hand it over to Giovanni.
Thank you, Alisa. So I'm Giovanni Vaccarino, and I'm presenting the project AI-powered chatbot for quick access to Jenkins resources. And my mentors for this project are Vutukuri, Chris, Bruno, and Berbianto. Next slide, please. So I'll start talking about me, and then about the project, and then we're going to dig into the details of the project. We're going to talk about the data pipeline of the RAG, the API, the UI, the testing, and finally, the future work. Next slide, please. So I'm from Italy, and I'm currently pursuing a master's degree at Politecnico di Milano in the computer engineering, and my main interests involve software development and AI, so machine learning, deep learning, and natural language processing. And with GSoC, this is my first open source experience. Next slide. So about the project, it obviously starts from an underlying need, and in our use case, the need is to provide to new users and beginner developers an easy and fast support throughout the Jenkins environment. So basically what we want to do is to decrease the steepness of their learning curve. And how we do that? We do that by building an AI-powered chatbot tailored for their use case. And in order to provide a quick access to it, we want to embed the solution that we're going to develop into a Jenkins plugin. Next slide. So we are going to start from a data pipeline, since we have a RAG-based chatbot, and then we are going to move to the development of the API that will serve the core functionalities of our chatbot. Then we are going to move to the UI part, and finally the testing part. Next slide. Starting from the data pipeline, we first had to identify the main data sources that we're going to use. And in particular, we chose those 4 that are the Jenkins documentation, the plugins documentation, the discourse threads, and the Stack Overflow threads. And for each of them, we had to go through a process of data collection, where for the threads, we could exploit some APIs or data tools to extract the data, while for the documentation, I had to rely on some web crawlers. After the collection phase, before moving to the chunking, we had to go through a pre-processing phase. And then in the chunking phase, given the process data, we are going to split the documents that we collected into smaller chunks. And those smaller chunks will, in the next phase, will be transformed into numerical vectors. And how we do that? We do that by using a transformer architecture, in particular a sentence transformer. And we chose an open source one that is all mini-LM. And finally, once we have the embeddings, in order to perform the semantic research and to store them, we are going to use a vector database. And in our case, we chose files. This way, we have a retriever where, given a query, we can extract the most relevant chunks of documents that we got from the documentations or the threads. Next slide. Once we've built the part that you can see in the image of the right that represents the retriever, the other main part was to build the effective API that will serve the basic core functionalities of the chatbot. In particular, it is represented by three main endpoints that are the one to create a chat, the one to send a message in a particular chat, and another for the deletion of a chat. So as you can see in the image, given a request, a first routing layer will handle the request, will filter them, and in case will forward the request to the service layer. And the service layer can use the retriever that we saw in the slide before, and then to generate the effective response, we'll use a provider. In our case, we are using a local running LLM. In particular, we chose Mistral 7 billion, but we build the entire infrastructure in order to be extendable. So in the future, we could include also, for example, the possibility to have API keys instead of a local LLM running. Next slide. Then we moved to the user interface. So the main idea was to integrate very well into the Jenkins UI and to provide a global and quick access to the chatbot. So once you have installed the plugin, you will see a button in the right part of the footer. And if you click on it, you will see the image on the right, the tab will open, and you will have the access to the chatbot, and you will have a multi-chat experience. Next slide. And here you can see another example where, starting from clicking the button, in the image on the right, we have an example of an ongoing chat. Next slide. We also performed the test for both the front-end and the back-end components, and we focused on both unit and integration tests. Unit tests to test in an isolated way the core functionalities of our repository, while integration test to test the main workflows of the chatbot that are happening. And also a little note about static analysis that we used throughout the whole development. We used both linters and formatters to ensure a consistent code formatting throughout the whole development. Next slide. And finally, what we will do in the following weeks, the focus will be on enhancing the quality of the responses given by the chat.
We lost Giovanni, right?
I think we did.
Either we lost him or he was just muted.
On
I
my
see him coming back.
No.
my
You're
Zoom
back,
coming
Giovanni.
back.
Go ahead.
Okay,
There.
sorry. I was saying while we are going to try to enhance the quality of the responses, we have to face the challenge of the response time, especially given our use case that we are trying to run the LLM in a local environment. And to help with that, we are going to see WebSockets that gives the opportunity of having a more real-time approach. And we will see if an agentic approach could be useful in our use case. Before moving to the questions, I would like also to say a big thank you to the mentors that for their availability and for their support. And I can for sure say that I've always received quick and meaningful answers throughout my project. So if you have any questions, I'm here. Mark?
Mark has a question.
Yeah, so Giovanni, you mentioned that you're doing scraping to get the data,
Yeah.
for instance, from Jenkins.io. Was there a compelling reason to scrape rather than to just request the source code from github.com? Tell us more about what motivated the choice to scrape.
Honestly, I didn't explore too much the option of following with GitHub. I watched a bit the Jenkins.io repository, but looking at the web, I thought that it could be also more automated, since I've developed also the whole pipeline so that in a Makefile you can run the entire process of data collection, and this could be more automated rather than a GitHub approach.
Thanks. Okay, thank you.
You're welcome.
So I've got another question, if that's okay.
Yes, please.
It's okay.
All right. So you showed in your screenshot what looked like a chatbot right inside the Jenkins UI. I'm used to thinking of the execution engines that do AI work as being backed by monster GPU clusters doing all sorts of crazy things, and that's not a typical Jenkins controller. Where's the execution happening to evaluate?
At the Yeah, at the moment we are using a local environment. However, we are running the LLM. The LLM can run also on a CPU thanks to the Llama CPP library. And also we are using not the full precision model of Mistral, but I chose a quantized version. It is a 4-bit version, so it is lighter than the effective. However, it would be good to provide also the possibility, if you have a GPU in the future, to exploit it to go faster.
Ah, okay. So it is in fact, I thought you were going to tell me, oh no, I've got secret thing hosted in the background, but no, you're really running it on the same machine as that Jenkins controller. Thanks.
Yeah,
Thanks
at the
very
same.
much. And that covered my questions.
Thanks, Mark. I don't think there's additional questions, so we can move on to
Um,
Birajit. Was there
We
another
have a
question?
comment. Not a question, but we have a comment from Diraj.
Very cool, Giovanni.
Thanks.
All right, Birajit?
Am I audible?
Yes, you are.
So, hello everyone. Good morning, good afternoon, good evening to all, wherever you are present. I am Birajit, currently pursuing my BTech in computer science. For GSoC 2025, my project is complete build retooling of the Jenkins IO, and my mentors are Chris, Bruno, Kevin, and Rajib. Yeah, next slide, please. More about me. I am pursuing my degree from Newton School of Technology, Pune, and I'm passionate about open source and DevOps. And my journey officially began with Jenkins in November 2024. Since that, it's been like a fruitful journey, contributing to the project and communicating with all the maintainers and the other contributors. You can check out my updates and my walks on GitHub and LinkedIn. Next slide, please. So here, what's we are covering today. We'll begin with a project overview. Look at the tech stack that powered the transformation and the migration. Walk through the migration strategy and highlight key milestones. Then I'll take you through our pivot to Gatsby, from Gatsby to YJS. Unpack the technical challenges or more importantly the learnings. And I'll give you a quick demo and end with a preview of what's coming next. Let's get into it. So, next slide, please. So for the heart of the project, for the Jenkins IO side, the project has started years before, and for now, the site uses tech stack that has been outdated, or more primarily we can say it's been not been maintained for years. So for us, we had to retool the entire Jenkins documentation site with a modern tech stack that's fast, maintainable, and aligned with the direction of how Jenkins works. The idea wasn't just to review, but to think how we can present Jenkins to the open source world. That also meant aligning structure, content, and design with the present Jenkins IO side. And for that, we divided the project into two categories. For the version content, it is based on the LTS releases, and for the non-version contents like downloads, pages, roadmap pages, and participate pages, we use it in texted. Next slide, please. So for that, coming to the tech stack, none of this happens without the right tools, right? So for the tech stack, to manage version content, we use Endora, rock solid and reliable. Initially, non-version contents was built using Gatsby.js, but we'll talk soon about why we pivoted. Then we might change the tech stack for non-version side to YJS. And for the front-end UI, we have used Material UI, giving the clean, modern look users expect today. And all of our dynamic content like roadmap pages and the download pages for the metadatas and all are handled through YAML files, allowing the flexible content updates. And each choice was intentional, like selected just because it perfectly suited to our project. Next slide, please. So how did we migrate an entire ecosystem without breaking things? Like for the Antora side, I went folder by folder, creating new folders in parallel using the same structure to ensure consistency. This was powered by Python script, and also for accurate differentiating, I use Beyond Compare tool that was given by my mentors. Now for the White.js migration, that was more page by page migration. It aligning each page with the exact structure and routing of the paths that is followed by Jenkins IO. Next slide, please. So yeah, I have given a structure of how the migration strategy has been working till our midterm for the Antora and the White.js. Next slide, please. Okay, now let's talk about the milestone, what actually we have achieved till now. On the Antora side, we have seen the docs Jenkins IO repo with the latest content from the Jenkins IO using their custom Python GitHub API script to get the commits from the last 1 year to June latest 25 LTS. Also, we have fixed some broken links, navigation links across navbar and footer. And we have completed a massive PR which has a full bunch of changes for the LTS 2.504x baseline. Also, there were many folders in our docs repo which were Gatsby. So we have deleted that and cleaned up for that. And for the total number of updates, this had been done to around 15-16 PRs altogether. Next slide, please. So for the White.js side, we started a new repo with preview support, branch protection, and internet issue tracking for us. And we have migrated some critical site pages like roadmap, download, event, and many more, totaling around 25 plus till now. And we have tried to achieve 90% visual parity with Jenkins IO side, and also support for dark light mode. And for the dynamic loading, we have been using YAML loading to render the contents for some important pages so that it actually works without using static approach. Next slide, please. So in between the project, we had to change our tech stack from Gatsby to White for the non-version content, because we got to know that Gatsby was dissipated and also it has not been maintained for some years now. And with discussion around Chris, Javinek, Damien, and Gavin, we decided to migrate to White.js. Also, White.js gave us a blazing fast dev experience, more flexible configuration, and future-ready ecosystem. So yeah, it was a strategic pivot, and I think we made a great decision in it. Next slide, please. So for the challenges, like I would say there are more learnings than challenges. So early in the Antora part, several pages had broken layouts, incomplete docs, and a maze of broken part references. So we had to debug them all. Then for the Gatsby to the White migration, we needed precision, ensuring every page behaved the same while the underlying system changed. The EML data structure was like complex for making it to render in wide ecosystem. So for if one line of code is wrong, we can't even think of the whole website gonna break. And add to that, multiple PR have been stacked one upon another, all independent or dependent on each other. So we have to carefully rebase to main. Next slide, please. Also, one of the important tasks for us was the visual styling to Jenkins.io. It needed to be pixel perfect to at least match 90 to 95% of the site UI. So yeah, for me, the every challenge was like, I would say they are more of a learning, and it was tackled very calmly. Next slide, please. So we had an important discussion about security advisories and the security folder with Daniel Beck in between our project, and he gave some important points that I have mentioned here, like the strategy for the security page and for the approach we should follow. And he also mentioned some important points of version and non-version contents, and gave some invaluable points on like how we can integrate and what will be the approach to change the version and so. Next slide, please. So for I would show just a small clip of the important pages migrated to Vibe. Um, Lisa, can I share my screen now?
Yes, you should be able to share your screen.
Visible, right?
It's black screen for me right now.
Yeah, for me too.
Okay. Yep, I can see your demo screen now.
So yeah, for a demo, like I have used iframe suggested by Rajiv, so I can show the different deployment of the pages since some of them haven't been merged yet. Like for the header and the footer, it's for timing, it has been like this. We'll change and we'll use the components from Jenkins IO components repo. And yeah, for the roadmap pages, like with the functionalities the same as Jenkins IO, we have all the functional same, and the UI has been matched around 90% to that of the Jenkins IO. Like, and for example, in the download page, the change log will take you as to the non-version side part. And but for the upgrade guide, if we have click here, now it will not work, but project will be ready, it will go to the version side since upgrade guides are in the version part. So after integration, the part will follow the part exactly like Jenkins IO so that it works around everything. And for the precision styling, I have matched like the small pixel perfect things like some fading and so etc. have been done perfectly. And most of the pages have been correctly done here and there. And I can say that about 80% of the white side has been completed. And for the demo, like if we click on any of the pages, sub pages has also been running. For example, coming to the participate page. For example, the participate page, here are many sub pages, though we have completed that all the sub pages too. So yeah, that's for our white side, which we have completed till now.
Okay, so I
Thank
will
you.
go back to sharing my screen.
Yeah,
Yeah,
but
thank you.
please speed up because we're already out of time. Thank you.
So yeah, sure. So for the next slide, please. For the next part, we'll be finalizing the migration of all remaining non-version content, security advisories, blogs, and homepage. Also, we'll integrate the Enter and White side, and we'll do some UI refinements and also performance testing and SEO optimization. Next slide, please. So next slide. So I would like to thanks the org admins and my mentors, Christian, Bruno Varakten, Kevin Martins, and Rajiv Singh for their support and the time for our wonderful project. And if you did like to explore, you can explore here our different site, docs, white, and our my daily logs repo. So yeah, it has wrapped up my project, and I'm free to take any questions out there.
Mark has a question.
So we've liked having the Jenkins.io site as a static site that we could generate and thus host on a content delivery network. Will it still be able to be hosted on a content delivery network? Will it still be relatively static, or are you relying on a web server behind it? Are you relying on some processing behind it rather than just serving pages?
No, it will follow the same. It will be just a static site out.
Thank you. Thanks very much. That's great.
Thank you. There is no open question. If ever you have some, write them down, and if we still have time, we'll ask them at the end of the session.
Hello everyone, and my name is Chad, and I'm the GSoC contributor for the project, which is domain-specific LLM, which is based on the actual Jenkins usage using CI's Jenkins.io data. And my mentors are Chris, Bruno, Hirsch, Shive, and B. So today's agenda is going to be like a little about me and the project's vision, and then why we pivot from fine-tuning to the agentic approach, then how much progress we have made so far, and what are the changes that we are going to make from the prototype that we have currently, which is working, and we already have a demo for that ready, and we already shown that. So yeah, and from like going from prototype to the target system, how many changes we have. A little about me. So I'm a final year student from BITS Pilani, and I'm currently pursuing MSc Mathematics and PE in Electronics Instrumentation. So I'm doing 2 degrees at the same time. Some experience that I have while I have worked in multiple startups while I'm still in college, and most of them were like AI related or automation related. So my main focus has been on like building multi-agent pipelines and some relevant open source contributions which were made during the time when I was trying to make my proposal for GSoC, which are like I contributed to Chaos OpenVINO backend, where we had to make a few backend using OpenVINO for Chaos. And then I also contributed to Agno, which is an open source agentic framework, which we are also using in the project to make making LLMs and using MCP and other tools easier. Next slide, please. So why are we like building this? What is the problem? The problem is like CI/CD debugging, which can be really time consuming even for experienced developers. Sometimes it is time consuming, and we would like to save the time. And as they like to have a lot of experience, they can do a lot better things. And if we are able to like save the time in this, it's gonna be great. Also, it's like kind of a steep learning curve for new users, and it can slow their progress down. So we are also like trying to help them out. Next slide, please. So what is the vision? Vision is basically an agent that can help you analyze and visualize the build logs and the failures that we are having because of that. We are going to like not make the user give all the files, rather we are going to give agent some tools which it can use to like access the file it wants to use or it wants to see. Maybe there's a file that has a problem, like maybe it's like flaky test failure. So the agent can go to the file and check the test, and it can say, okay, fine, this is the failure because of the flaky test, and you have to like improve the test, and it can give some suggestions as well, or some fixes, or maybe some resources that we have for these kind of problems. And we want to like mm, we don't want the developer to spend time in finding where the problem is, right? So it's also going to like give us the location for the file. Okay, fine, the problem is so in this file, in this section, and here's a fix. So it can save a lot of time. Even if the fix is not correct entirely, the developer will know where the problem is and they can fix it themselves. And also it can like lower the bar for Jenkins because we are also going to have a learning mode which will be there to help people learn about Jenkins and just help them using the project. Next slide. So why are we going from the fine-tuning approach that we initially like selected to the agentic architecture? Because it's more flexible, and when you are like fine-tuning an LLM, it can get obsolete real fast because LLMs come out every month. Like just last week we got Kimi 2, which is like a sort of model, and it's like performing way better than the models. And even the last month, the models that we got are not performing the models we got like 2 months back. So even if we like select the current best model on the market for our usage, it can get like it will like get obsolete very fast. We can get like a model next month which can outperform that model. So that's why we are like making an agent which can utilize the better models as they come out. And the fine tuning part is still a future goal, which can be done when we have something like a really steep curve for the LLMs, like at the point that they can't really go better than that. Maybe then we can fine tune some LLM and use that for the agent. Also, agent is limited by the tools it has. So we can also extend its capabilities by increasing the number of tools, which is going to be like really easy as it's not based on the training data that we have. It's just based on the like whatever new features that are coming out. Like no one knew about MCP last year, but it did came out last year. Everyone got into the craze of MCP this year. So maybe something like that in future. Yeah, next slide. So what the core architecture is looking like? First, we have like one universal agent, which is going to be like working uh, for the agent. Like it's not just an agent actually, it's like a whole pipeline. It has a lot of agents in it. One of them is going to be an agent that's going to select the problem category, and then we have multiple agents, one for each category, which are going to have one critic agent as well. So the main agent and the critic agent are going to converse, and they're actually like conversing as in the critic agent is going to try to like identify the problems with the main agent's responses. And this architecture actually increases the quality of the responses a lot. And we will have an option where the people can turn the critic agent off as well if they want to save some tokens and if they want a faster solution to the problem. So we are making a lot of backends. Like we are giving many features for the like user to use in their agent that are like we have backends like OpenAI, Cloud, Grok, and we also have some self-hosted LLMs which we can be used as a backend, which are like given through VLMs and OLAMA and all. Next slide, please. Okay, so the progress till now. At like current point of time, we have a functional streamer prototype, and we are going to build on that prototype. We have the modular agentic framework, in which we have made the LM API adapter part, which will be used to like give access to the multiple backends to the user. And currently, we have made that for OpenAI, Anthropic, Grok, and I think we have also given that for the Open Router. Open router is a like router through which you can use like various APIs. And we might even like change the user interface part. We can also go from Streamlit to maybe a whole front-end website for it, or maybe even a CLI app, which will depend on how the project progresses. Next slide, please. Next slide, please. Hello. Yes. The current state is like the user is going to have a streamer interface, and then we have a monolithic pipeline where we have hard-coded agents, static prompts, and a basic sandbox file reader and the local workspace. But this is going to change soon, as we are not gonna like provide a basic file reader. We are going to have a rather MCP tool, which is going to like get all the bills, get the status of the bills, and also like get the files. And then the agent will be able to like use a file reader, which is going to be having a lot of sanitization so that there cannot be any API or any critical information that is going to be given to the LM. Everything is going to be like sanitized. But to the user, it will look like we have been giving that specific information to the backend as well, because you're going to map them and we are going to have the keys as well for that. So whenever information goes to the LM and when it comes back, it will come back with the keys, and we're going to replace those keys so that user will know whatever the information is being filtered out, but LM won't be getting anything. So it's going to be like a lot more secure. Next slide, please. Like the target architecture will be like one modular pipeline, which will have 4 modes. Then each of the mode is going to have an agent as well as a critic agent and some router agents as well. We are going to have MCP tool, a light track tool. Light track is a like really advanced version of track, and we are going to have an LM adapter for that as well. And the scores for light rack are like way better than vanilla rack and the traditional rack, and are as compared to the like graph rack, but it's like really cheap and it's also like really fast. And we're also going to like include testing, which is like unit tests for each and every feature that we're going to have, and also the whenever we are making any of the new parts of the agent, like when we're making the LM adapter and we're making the agents. We are also like adding tests to it so that we will know like if there's any problem in like making the agents, or if there's any problem while we are making the prompts, because now the prompts are not in the file with same as the agent. Rather, we have like one empty markdown file for each and every agent to make it easier to change the prompts as well. Thank you. Next slide. So our future milestones are going to be like Jenkins integration, in which we are going to use the MCP tool, MCP server, which is already made, like the MCP plugin, sorry. And we are also going to like use RAG for external knowledge, which where this is where like the light drag tool comes from, and also like a comprehensive evaluation framework, which will be used to like test model on various LLMs, and also like various kind of sanitizations which are going to provide, which is going to be like one like a really harsh sanitization where we are like removing a lot of bunch of information, somewhere like it can save a lot of tokens to the people, like to the user. And then we are going to have like a light sanitization where like not too much information is going to get sanitized, but that is going to definitely increase the token size. So it's gonna use more tokens. So it will depend on the user. And we will also like evaluate what are the metrics on those specific level of sanitization. Thank you for your time and guidance. Any questions?
I'm afraid we don't have time for questions.
That's why I like rushed it a little bit.
Next one, me.
Hi. Hi everyone. My name is Maeve. I am a contributor for the Improving Tekton Client plugin for Jenkins projects, and my mentors are Deepav, Chris, and Bruno. A little bit about me. My name is Maeve. I am rising junior at Lehigh, studying computer science. And the project represents a significant step forward the cloud native CI/CD integration, bridging the traditional Jenkins workflows with the modern Kubernetes native Tekton pipelines. Next, please. So this is what we are covering today. First is a little bit about the Jenkins Tekton plugin, then the plugin status before the improvement, the project goals, the key contributions, a demo of the code, and the future plan. So first let's talk about the Jenkins Tekton plugin. As we all know, Jenkins is a widely used CI/CD automation tools that most of you are probably familiar with. And Tekton is a Kubernetes native framework for creating CI/CD system that runs directly on the Kubernetes cluster. The Tekton client plugin for Jenkins allow users to trigger and monitor Tekton pipelines directly from Jenkins pipeline. This means that we can leverage Jenkins' rich ecosystem and familiar interface while getting the benefits of the cloud-native execution on Kubernetes from Tekton. Next slide, please. Then let me walk you through the current state. The past state of the plugin before our improvements. First, it had an outdated foundation. It was using Java 8 and Jenkins parent version 4.18. And secondly, there were significant testing gaps. It only had JUnit 4 without modern test patterns. And especially, we didn't have any end-to-end tests. And finally, it had limited functionality. We were missing the support for dynamic Tekton CRDs and robust integration patterns. Next slide, please. So based on these issues, we established clear goals on our modernization effort. Our primary goal was to stabilize and modernize the Tekton client plugin, make it more product ready. We wanted to improve the test coverage and the CI setup, replacing the unreliable testing infrastructure. We also aim to build the support for dynamic Tekton hierarchies, enable more flexible integration patterns. Our long-term vision is to convert Jenkins pipeline into the native Tekton pipelines, providing a migration path for teams. Next, please. So for the key contribution, let me walk you through the specific technical improvements that we made. First, we fixed the build for Java 21 and Jenkins 2.440. This is a critical compatibility with modern Jenkins installation and also involve updating numerous dependencies and API calls. We migrated 21 unit tests from JUnit 4 to JUnit 5, modernizing the test suite with better assertion, parameterized tests, and improved the test lifecycle management. We also rewrote broken test logic to align with the more up-to-date plugin behavior because many of the existing tests were failing because they were expecting the outdated plugin behavior. And we also created and configured GitHub Action CI pipelines. What is particularly important are our E2E test pipeline. So you can see, so we added 4 new E2E tests to increase the real-world coverage. These tests simulate complete integration scenarios. They just spin up kind Kubernetes cluster, install Tekton, and then create the Jenkins job with our plugin, verify that the Tekton resources are created and executed successfully. During the next slide, please. So I want to discuss about the end-to-end workflow diagram. That is the foundation of the end-to-end test that we mentioned. So yeah, we have our cluster and Tekton setup, and we can install the Tekton and then create the Jenkins work with our plugin. So the Jenkins test job with the plugin test, and the result will be validated. Next slide, please. So in the first image, we have integrated GSoC code coverage reporting, which currently show that we are having 20 this overall coverage with detailed breakdowns by package. As you can see from this report, we have a good coverage in core area like build package at 73. However, the other area like logwatch need more attention. So that will be one of our future testing efforts as well. And for the second image, the E2E test, this basically show the whole workflow of how the E2E test run as I mentioned before. So this is supposed to be a demo. Alyssa, can you play it for me, please? I will explain along the video. So first, I am checking the Java version. We are running it on Java 21. Then I would just install the plugin using Maven install. So the plugin will automatically, and then I just run the E2E test that I mentioned. The second window is the Docker. So one of the most important requirement for running the E2E test is that we need to have our Docker installed. And while running the E2E test, we can see that there will be some container pop-up named Tekton E2E test with the container ID. That is also a part of the that E2E test while running locally. So it should be creating its own Kubernetes, like the kind cluster, and get and use the kind cluster as the resource for Tekton execution. So yeah, that's basically everything. You can see test run 8, test run 12, success. Yeah, that's everything. That yeah, that's the end of the demo. Next slide, please. Oh, thank you so much
Hold on.
for.
Is
Thank you
there
so.
another slide? Hold on,
Oh
let
no,
me
there's
get
just
back to
like
that.
a question. If you have any question.
Okay. Okay, then let me
Um,
stop sharing here and then I go back.
Yep.
Yeah,
So
we may
yeah,
have time for one question.
Yeah.
And I take that for a no.
bear with me. I'm trying to get back to my slides.
Yeah.
Okay. I'm ready to go now. Okay.
Hello, am I audible?
Yes, you are.
You are.
Hi everyone, I'm Ronak and I'm working on the project Improving Plugin Modernizer. And my mentors are Valentin, Bruno, Sridhar, and Philip. Next slide, please. A little bit about myself. So I'm an undergraduate student pursuing BCA from Bharatiya Vidyapeeth, and I'm based out in Delhi, India. And I'm really passionate about cloud native technologies and open source software. And it all started after my first KubeCon in India. So I started my journey with Jenkins in December 2024, and I'm really grateful to be a part of this wonderful community. You can check more of my work on GitHub. So in today's, we will be discussing about the plugin modernizer, which is our project, and the existing scenario, and how are we improving the metadata storage, progress we have made till now, some visual representation of how things are working, and demo, future plans, and then we will end up with the questions. Next slide, please. So what is Plugin Modernizer? So it's a generic CLI tool that automates the modernization of Jenkins plugins. So it applies code refactorings and transformations to a plugin so that we don't have to do it manually. And after applying the transformation, it validates the changes and creates pull requests to the respective plugin repository. So why do we need it? Like with over 2000 plus Jenkins plugins, it's a quite big ecosystem, and keeping them updated manually is quite a big task. So it makes life easier for our maintainers. And how are we doing it? We are utilizing recipes. Recipes in Open Rewrite are a set of transformations that update code patterns via updating the abstract syntax tree. And we also have our custom recipes built on top of Open Rewrite that helps to modernize the plugin and make sure we keep the plugin updated. Next slide, please. So let's talk more about modernization metadata. So it includes things like the PR URL made by the CLI tool to the respective plugin repository that it is modernizing. And it includes things like, did the migration succeed? Did the PR got merged? So the PR here is the pull request that the CLI tool made to the respective plugin repository. And why do we need to track the modernization metadata? So we need to track it because we need to make sure that we know what recipes are failing and what are successful, and like what PRs made by the CLI tool, what are all are merged and open. And it also helps to identify what recipes are failing on what plugins so that we can debug that recipe and improve upon it. It also helps to measure technical debt reduction. So currently we are storing the metadata on an Excel dashboard, but we need a more streamlined approach to track the impact of the CLI tool. Next slide, please. So how are we improving the metadata storage? So whenever someone runs our CLI tool, it applies the modernization to the plugin, then it validates the changes and makes a PR to the respective plugin repository. And additionally, what we are doing now is we are also extracting the metadata of the modernization and the pull request. And after extracting the metadata, we push it to a central open source repository. And then we have the GitHub action that validates and auto merges the PR. So there's no manual intervention. And we also have some other GitHub actions that does recurring updates on the metadata, because this metadata is dynamic information. Like, for example, we are tracking the pull request status of what the CLI tool made to the plugin repository. So let's say the pull request that the CLI tool made got merged. So we also need to update the metadata that the status is merged now. So we are doing that via a cron job. And we are also extracting useful reports from that metadata. Next slide, please. So some fields we are able to track are the pull request URL that the CLI tool is making, the status, the checkruns information of the PR, the Jenkins baseline, target baseline. We are migrating to the migration status that is like important, success or fail, and the diff statistics, the number of editions it does and changed files. We are also consolidating all the metadata for each plugin in an aggregated migrations file. So let's say for plugin A, for each plugin, we would be having this aggregated migrations file that have all its migration listed, that is being made by our tool. We are also generating reports, the PR stats, the migration success and fail stats, and list of all the plugins with failed migrations. Next slide, please. So let's visualize how different components fit over here. So we have a CLI tool and we run it, and it modernizes the plugins, makes a PR to the respective plugin repository, and then it extracts the modernization metadata. And then after extracting the metadata, we push it to a central repository. And then over there, we have GitHub actions that validates and auto merges that PR. And then we have another GitHub action that updates the metadata regularly. And another GitHub actions does generate reports and does all the aggregation and consolidation. Next slide, please. So we have a demo video. So as you can see over here in the first line, we are running the plugin Modernizer on Tulip OAuth, and the recipes upgrade next major parent version. So we cloned the repository, verified the state of it, and collecting metadata. And now it will make two pull requests, one to the respective plugin repository and one to the metadata repository carrying the metadata about the modernization. So let's talk more about the metadata pull request. So as we can see over here, it will get auto merged after the successful validation. So yeah, and what we are storing over here is details like Jenkins version, effective baseline, target baseline, the migration status, that did the migration succeed or not, the pull request URL, and things like that. And moving on to our another workflow, update metadata. So it updates the metadata, as I mentioned, via a cron job. So it's updating, it's internally using a Python script. So it will make a pull request back to the metadata repository to merge the changes. And we have now the check runs information of the pull request, the status of the pull request, and the default branch commit SHA and things like that. So yeah, and moving on to another workflow, we have consolidate metadata. It will consolidate all the metadata for each plugin. So we have, it is also using a Python script internally. So we have aggregated migration, like when see over here, we have aggregated process 227 plugins. So 2000 plus lines of code. So yeah, it's, and as we can see in the left side, we have aggregated migrations.json for each plugin. And then moving on to our last workflow, we have the migration reports. It will generate some useful reports that will also be consumed by the Jenkins report site. So it will also generate a summary of, it will like generate a high level overview of what we are doing and tracking the impact of the CLI tool. Like it has all the failed migrations.csv file for every plugin, so that we can see what migrations are failing for individual plugins. And the directory structure seems something like this. So we have all these plugins, the metadata of these plugins. And in the reports directory, we have summary, the total migrations, the failure by recipe, and plugins with failed migrations. And also we are having the pull request statistics, how many PRs got merged, open and closed. And we are also having a recipes folder where for each individual recipe, we are having all its application across different plugins. So for this upgrade next major parent version, it got applied to these many plugins. So we have all these for that. Next slide, please. So for the future plans, we will be pushing the consolidated metadata to the Jenkins report site and visualizing it on the Jenkins statistics site. Also, we would be automating running recipes on plugins with low health score based on their failing probes, and adding and improving recipes. Like we may add a recipe for migrate plugins to Java 25. So yeah, next slide, please. Thank you for your time. So feel free to ask any questions about the tool, about the future plans, or how we are doing things.
So I think we're over time. So what I suggest is that we take questions to the Discourse and or the GSoC Gitter channel, so we can continue the discussion there. But I wanted to share, there's additional resources on our website, jenkins.io. And if you'd like to be involved in future GSoC programs, we would love to welcome new mentors. But other than that, wanted to say thank you to all of our mentors. Without them, this program is not possible. And thanks again to all of our 5 GSoC contributors. We do appreciate your contributions to the project. It does make a difference, so keep up the great work. So thanks everybody for joining. We'll chat in the Gitter channels. Have a good day, have a good afternoon, and have a good night. Thank you all.
Thank you. Bye-bye.
Thank
Bye-bye.
you.
Thank you.
Bye-bye.
Bye.
Thank you,
Hi
everyone.
everyone.
Bye.